everyone, this is Ray, and I was assigned section 4.8, number 6, question number 6, and it was giving me, this is the limit is approaching, x is approaching 1 from the right side, and yes, well, first thing I'll do is just plug in 1 for wherever there's x, so log natural of 1, that gives you 0. And then times tan pi over 2 times 1, which is pi over 2. When you do, like, this is pi over 2, you have sine is 1, or cosine is 0, and sine is 1 for the y value right here, if you can still see that. And so I know that tan is sine over cosine. So if I plug in 1 for sine and 0 for cosine, I have this undefined. So I know if I put it in a graph form, and I put, here's 0, here's pi over 2, and here's pi, I know that it's going to have an asymptote here, and also know that it'll have an asymptote at 3 pi over 2. And so it'll come down, hit here. There'll be like a point right here. So just imagine that that point is actually going through here. And then it comes down, and it'll never reach the asymptote. But the behavior of the limit that it's going to negative infinity from this side, and it'll also be like this for 0. This will be like negative pi over 2, for example, and then it's crossing through here, so it'll be positive from this side for negative pi over 2, or for positive pi over 2. This is 0, so just like an idea of this is going to be positive because it's going up, this is going down from the right side. And so yes, next, now that I know that this is the behavior of the graph, or the limit, I'll just put negative pi, negative infinity for this side. And whenever I have one of these, I know that I should take the reciprocal of my limit. I'll split it into 2, and then the professor just said you can't put log natural on the bottom, so I'll do tan over pi. Oops, I'll do log natural on top. As the limit is approaching x, this one is equal to log natural of x over 1 over tan pi over 2. I know that 1 over tan is pretty much cotangent, so for the next step I will do log natural x over just cotangent pi over 2x. And then the next step is to evaluate this. So I'll write evaluate next to it. So I know that log, to see if it's going to be this or this. To get to L'Hopital, but first we'll evaluate. So we have the log natural of x, which is 1 over x, and the cotangent of, oh, sorry. Before we get to that, I almost made a mistake. So we're still evaluating the limit. So x is approaching 1 plus, so I know that 1 log natural of 1 cotangent of pi over 2. And so now I have, did I make a mistake? Let me just check. Over the cotangent. Yes, okay. On the right step. Yes, continue to evaluate. So now I have this and this. So I know log natural of 1 is 0, and then cotangent of this would be, we'll go back to this conversion. So 1 over tan pi over 2. We already said that this is going to be negative, and so it's going to be 0. Because this is an infinitely large number in the bottom, and divided by 1, so it'll be 0. So now we have 0 over 0, and we could do L'Hopital. So then I'll go next. The limit. This x is approaching 1 first. So I finally take the derivative now. So I have the derivative of log natural. I'm just going to write it down first, and then I'll move it over. Cotangent of pi to x is equal to, now we're doing the d of x dy. So I have 1 over x for the log natural, and then the cotangent is going to be negative cosecant pi over 2x. And then this is the first part, and then I have to go and look inside here, and I have that it is going to be times pi over 2, because this is going to be 1 minus 1, which is 0. 0 times x to the 0th power is 1. That's how you get that for the inside of the function. And so now I go down again, and I can simplify this. I have 1 over x is negative cosecant pi over 2 x times pi over 2. Cosecant is 1 over the cosine, and pi over 2 times pi, and cosine at pi over 2 is 0. I just want to check again, right? Once I have this, yeah, plug in 1 over 1, negative cosecant. Oops, it's 1 over the sine. That's why I was confused. My bad. So 1 over sine. It's actually squared. It's just squared. But cotangent is squared. And so I have pi over 2 pi over 2. I know that's going to be 1, so it's going to be 1 over 1. This is equal to 1. And then so I'm evaluating now, so I'm doing 1 over 1 for x, because the limit is approaching. X is 1 plus. And then cosecant, we determine that's going to be 1 over the sine, so it's going to be 1 negative 1 squared for this one, times pi over 2, which is going to be, this is just 1, it's going to be negative pi. So then I have 1 over negative pi over 2. And then I can further simplify this, and I do a flip switch. So I'm doing negative 2 on the top. So I'll have my final answer as negative 2 over pi. And that's the work.